Early industrial control systems placed all the control hardware in one room. Wires ran hundreds of meters to every sensor and valve across the plant. If that central computer failed, everything stopped. If a wire corroded at the far end of the facility, the whole loop went down. Engineers needed a better architecture. The answer was to distribute control. Move the decision-making closer to the process. That is what a distributed control system does. A distributed control system is a computerized platform that controls and monitors continuous industrial processes by spreading control tasks across multiple local controllers rather than relying on one central computer. Each local controller sits near its process area and runs its own control loops autonomously. The controllers are connected to a central operator station through a high-speed control network. The word distributed describes where the control logic executes, throughout the facility, not in one room. Local controllers are microprocessor-based units placed near physical equipment. Each one reads sensor data, runs control logic, and drives actuators without waiting for instructions from a central machine. Sensors and actuators are the physical layer. Sensors measure temperature, pressure, and flow. Actuators open valves, start pumps, and stop motors. The human-machine interface is the operator workstation in the control room, where process data is displayed and operators issue commands. The data historian is a specialized database that records every process measurement over time for analysis, audit, and regulatory reporting. Programmable logic controllers handle discrete, sequential tasks. Do step A, then step B, then step C. Assemble parts, package products, move items down a line. A DCS handles continuous process control, chemical reactions, distillation columns, temperature and pressure loops that run without stopping. A large refinery has thousands of these control loops running simultaneously. At that scale, a DCS integrates the entire plant's control, safety systems, alarms, and data logging into a unified architecture. A PLC handles a machine. A DCS runs a plant. SCADA systems are built to supervise large, geographically dispersed infrastructure, a pipeline running 800 kilometers, a power grid spanning multiple substations. SCADA collects data from remote sites and gives operators visibility across that distance. A DCS manages localized, highly integrated, continuous processes inside a single facility: the oil refinery, the chemical plant, the pharmaceutical manufacturing floor. Where SCADA handles geography, a DCS handles depth, tighter integration, faster control loops, and direct connection between the control system and the physical process in one location. Oil refineries and petrochemical plants use DCS to manage the continuous chemical processes that never stop. Pharmaceutical manufacturers rely on DCS for batch processes, where precise temperature, pressure, and timing determine product quality. Large power generation facilities use DCS to control boilers, turbines, and generators. The common thread is continuous or batch processes at scale, where thousands of control loops must run reliably and where the cost of integration failure or unplanned downtime is high. In those environments, distributing control across local controllers is not optional. It is the architecture the process demands. This lecture is part of the free Introduction to Industrial Control Systems course. 25 lectures, no cost, link in the description.